would have caused a dangerous lowering of the surrounding water level, undermining nearby buildings. The solution was to construct an underground concrete retaining wall to surround the site. This was built with the slurry trench method, used for the first time in this country. A trench was dug down to bedrock, and a thick bentonite slurry was pumped in. The slurry was denser than the surrounding mud and dirt, and thus kept the trench walls from collapsing. As each section was completed, 25-ton cages of metal reinforcement rods were lowered into the slurry-filled trench. With the cage in place, concrete was poured in. Since the concrete had a greater density than the slurry was forced up out of the trench and could be used for the next section. In this way, an underground wall was built completely sealing the site. Excavation began. As each section of the slurry wall was revealed, workers drilled holes through the wall and casings were pushed through down to bedrock on the far side. Steel tendons were then inserted through these holes and socketed into bedrock, bracing the wall against external pressure. More than 1 million cubic yards of dirt had to be removed to make way for the Trade Center's foundations. The excavated earth was placed in the Hudson River adjacent to the site to create more than 23 acres of new land which was donated to the city of New York. The site presented another major challenge. The tubes containing the PATH commuter rail lines lay underground within the excavation area. The fragile tubes had to be supported in protected cradles while excavation continued around them. Throughout construction, the PATH trains carried 130,000 commuters daily. At no point was service interrupted. 7 stories down, bedrock was finally reached. Foundations for the towers could now be prepared. Concrete footings were formed and poured into bedrock. Massive assemblies of steel beams called grillages were laid on these footings. Each grillage would anchor one of the load-bearing tower columns. Meanwhile, orders were placed for the 200,000 tons of steel which would be needed for construction. Individual pieces were rarely interchangeable. Moreover, there would be no room to stockpile materials at the construction site. This created a tremendous logistical problem. Steel sections would have to arrive at the site in the exact order and at the exact time needed. To meet this challenge, Port Authority engineers used a computerized system known as Critical Path Method, or CPM. CPM would coordinate every aspect of construction, track the flow of materials, and minimize any delays. In August 1968, actual steel construction began. Kangaroo cranes, imported from Australia, were used for the first time in the United States. The cranes were assembled on top of the core columns. Each could lift 60 tons at a time. They would be the driving force behind the tower's construction. The cranes had the ability to jack themselves up 36 feet at a jump. As the walls grew to the height of the crane would hoist itself up, a neighboring crane would swing core columns into place beneath it, and construction would continue. 70 feet up at street level, steel trees were put into place around the perimeter of the towers. These trees would transfer the load of the exterior wall to the more widely spaced columns now anchored to bedrock. Construction of the towers could now proceed with great speed. 3 basic elements were used: 2 or 3-story high sections for the load-bearing wall, massive steel beams for the core columns, and floor sections to span the 60 feet between core and wall. Through the complex orchestration of these structural elements, 3 floors could be constructed in 10 days. its many engineering innovations, the Trade Center was cited as the outstanding engineering achievement of 1971. Shortly after the structural completion of the towers, the surrounding low-level buildings were finished. final addition to the North Tower was a 360-foot television antenna erected in 1978.